Morning.
Morning.
Having lots of technical difficulties over here. This morning, my internet went out and I went to my wife's work hotspot. And now I called, there's an outage, and it came back on. But just now it looked like it went off again temporarily and then back on. So if it happens again, we get kicked off of this thing, come back, because I'm going to use my wife's hotspot, but you'll have to wait, be patient. Just log back in and wait for me to log back on again. Don't just say, oh, it didn't work out, we'll meet again tomorrow. Just try to come back and, try for like 5 minutes. Give me time to get it back up. That's in the case that it comes back out again. Okay, let's start working on this challenge problem here. Oop. There. You guys can see the screen, okay?
Oh, wait, Mr. Rosenthal, do you know when our textbook returns will be? Like our grade?
It's like Thursday, Friday, and I don't know what last names go when.
Oh.
That's whatever the school put out to you. I just know the days are this Thursday, Friday.
Oh, okay.
Our last class meeting will be this Wednesday.
Yay. Oh, well.
Yeah, no, I mean, and, this is for you guys. This is so that you guys can get a little bit of math, get a little bit ahead for next year. It's not that long. It's not the full 90 minutes. It's just, an hour. And then you get, a teacher to try to understand this stuff so that when you go in, you guys will be in a position to take the AP Calculus exam in 2 years from now.
Okay, 2 questions.
Yeah.
One for Mr. Rosenthal, one for the 7th grade class. Actually, no. Mr. Rosenthal?
Yeah.
If we found these, me and Daniel and Son found these season summer classes.
Uh-huh.
And I was going to take Algebra 2, and apparently they're cramming the entire year into 5 weeks.
Yeah, I don't. You can do it, but it's not going to count on your transcript so that you can bypass.
Okay.
We don't have a pre-calculus class at our school, just so you know.
Oh.
We only have advanced math. Advanced math means you're taking Algebra 2 and pre-calc in the same year. So you can't, it's not like you can go to the summer class, take Algebra 2 and say, okay, can you put me in pre-calc? We don't have a pre-calc class. So there wouldn't be a class for you. All right. And so if you want to do it, I would do it for the only purpose of brushing up on it before you go in. But if you're not worried about that, now there is something to that. This next math year is an accelerated year. You're doing 2 years in one. It's already going to be accelerated.
Oh yeah, I'll do 2 and pre-calc, yeah.
Mm-hmm. So, and the thing with that is it's hard to finish everything so that you guys are ready to start calculus on time when you do calculus the following year. And what ends up happening is... It
would help if we did Algebra 2. It would help.
If you guys go, let's go past next year. You go into calculus AB the following year in your, let's see, you guys are 7th graders now, and some of you are 8th.
I can't understand you. You're cutting in and out.
I'm like a robot.
Can everybody else hear me? No?
He's still cutting in and out, right?
Yeah.
Now?
Yeah.
No.
Cutting in and out, huh?
It's just like
Something's up with his internet.
There
he's back.
I'm really back.
Andrew was a host, and they were trying to get him to turn on everyone chat.
Can you guys hear me now?
Yes.
Okay.
Maybe we can still message Joe.
All right.
Still message Joe, but that's it.
Okay, I'm on my wife's, I'm on her hotspot. So I have an outage. They said it could be fixed around 9:30, but that it could be sooner. I saw that it came back on, so I thought, oh, they fixed it. But it looks like they're working on it, so it's going in and out. All right, so anyway.
While you were gone, Andrew Cho became the host.
Oh, seriously?
Yeah.
Yes.
If you just pop out, a random person becomes the host.
Okay. Is he still the host?
No. Oh, it gave us a notification when you log back in.
Reset back to you.
Good. Okay, good. All right, so here's our... Okay, so what were we talking about just now? Oh, yeah. Okay.
Algebra 2 and stuff.
Yeah. Okay. So here's the problem. The acceleration year, it's the 9th grade year, and for some of you, it'll be your 8th grade year. The acceleration is taking place, and trying to accelerate and get Algebra 2 and pre-calc in 1 year, it often is the case that when you get to Calculus AB the following year, that you need too much pre-calculus review or to finish it, and so you don't end up getting enough calculus to be ready for the Calc AB test. So, but that's okay. I mean, if you take the Calculus BC, it supersedes whatever you get on the Calc AB test. So just taking Calc AB, AP, Calculus AB, you get the AP credit. You don't have to take the test to get the AP credit. You know, getting an A in AP Calculus AB, you get the credit for the course. But the college credit, if you take Calculus BC, I think it supersedes you. Now you can confirm this and check it. I don't think that you get, I'm not sure if you get AP credit in the colleges for different calculus courses. I think doing the BC allows you to, and I don't even know if some colleges will even say, oh, you don't have to take calculus anymore. I don't know if they'll even do that. They might make you, depending on the university, they might say you need to take calculus again anyway because you didn't take it with us, and we want you to get it from our professors. So they might pull something like that. It just depends on the college. But you'll have to talk to a college counselor or the counselor just to make sure. Mr. Canals knows about that kind of thing. So anyway, it's helpful. What I'm doing here is I'm saying it's helpful to get as much as you can. So what we're doing here, that's a justification for why continue in this last week, why try to go any further. The further we can go, the better it's going to be for you if you can get yourself prepared to take, AP Calculus, the whole course when you get to it. All right, let's do this problem. Who's been doing it the whole time I've been blabbing? Anyone?
Not I.
Okay, so profit. We did one like this. So you have a profit that's in millions of dollars for a DVD manufacturer, and it can be modeled by P equals negative 6x cubed plus 72x. And x is the number of DVDs produced in millions also. Show that 2 million DVDs is the only production level for the company that yields a profit of 96 million. Well, to me, what stands out when they're saying that? They want us to show that could be the only way that you can produce it. What in your mind mathematically does that tell you?
They want
There's
to make
only
sure.
1 0.
There's only one or it's a square, right? At that 0. It's like the same thing times itself, so that only yields 1 0, right? That's what I think is going to happen. I think you're only going to get the 1 0 when you solve this. So go ahead and what are you going to put in? What are you going to do right now? What are you going to do to start this problem?
I really don't know.
Well, what information did they give you?
The function.
So you have profit is equal to 96 million. So set 96 million is equal to negative 6x cubed plus 72x.
So basically you're saying substitute for P.
Yes.
Okay, so David and everybody else, in the very bottom, the last word.
Oh, we can divide by 6.
So yeah, but you're not going to put 96 million because P is already in millions.
You just put 96.
Exactly. So there's your profit. And what they're saying is the solution, when that's the profit, can only be the x has to equal 2, right? Because that's x is in millions. So x is going to have to equal 2. So by solving this, we should show that. So you're basically using the math you learned to do that. So let's go through the process. Okay, and we're going to make that 0, right? So that we can use our factoring and our dividing. Okay, and let's divide everything, right? So does 6 go into all these? Yeah, 6 goes into all of these, right? So maybe I'll even divide by negative 6. Divide by negative 6. Divide by negative 6. Divide by negative 6, that'll make that minus, so I'll get 12x. Divide by negative, so that'll be positive. 6 goes into that 16 times. Okay, All right. Any questions so far? I'm going to go to another color. All right. All right. So now what are we going to do?
We need to find the factor. We need
they're
to find the
suggesting
factor
a solution.
that divided yields. We need to find a factor of that equation, or yeah.
Okay. How are we going to find that?
With the first
You have
term.
an x cubed in the way. I'm guessing polynomial division.
Well, they're
Divided by
saying
what?
they suggest an answer. They suggest a solution that x is 2. So k being 2, or x is 2, they're suggesting that this is a factor. X minus 2 should be a factor of that then, if they're correct, right? And they're suggesting that 2 is a solution already. So x minus 2 should be a factor, because if 2 is a solution, x minus 2 gives you a 0, right? What if x is 2, 2 minus 2 is 0. So x minus 2 is a factor. I'm using synthetic. If you want to use long division, divide this polynomial by x minus 2.
You get a remainder.
Okay, now be careful. The coefficient here is 1. There is no x squared term. I messed that up last time. I need to put a 0 for the x squared term, negative 12 for the x to the 1 term, and x to the 0, you get a 16. Bring it down.
Wait, Mr. Rosenthal, how do you know that 2 is one of the factors?
Because they said 2 million. Show that 2 million is the only
Never mind,
production,
I forgot the 0x squared.
which
Oh, okay.
suggests that 2 million is a solution for x, right? It's the number of DVDs, right? They said x is the number of DVDs in millions. Okay, then I add. 2 times 2 is 4, and then I add. 2 times negative 8 is what? Negative 16, and then I add. So now these are the coefficients of a new, let me cut to my screen. Oh, and I have to repin. Okay, so these are the coefficients of a new polynomial that is left over after I divided out the x minus 2. So this will have a degree less than what I had. This will be 1x squared plus 2x minus 8, okay? And we want to be able to see what makes this 0. What are solutions of that? Well, now, let's see. Yeah, this can be factored. That's going to be x plus 4, x minus 2 is equal to 0, right? So I was wrong. It's not a square.
X minus 2.
No, there is a square because x minus 2 shows up again. Yeah, and we had one before.
You didn't put it in at first, I see.
Yeah. I'm going to go to another color now.
The answer is negative 4 million.
Okay, so solutions here, x here could be negative 4, positive 2, and also positive 2 from before. Okay?
So if they produce negative 4 million DVDs, they'll get 96 million in profit?
Yes, so right. So because this is extraneous, you can't produce negative DVDs. We X this out.
Wait, what if they're destroying 4 million DVDs?
That's not, that you're assuming that is what is equivalent to a negative. You're assuming that is what negative means. And
Why do you have
that assumption is false. Okay, what you
Why
see, hold on, guys, hold on. Let me just finish the thought. What you now see, because that's extraneous, that the only production level available is 2 million shoes to be
Where'd you
produced.
get 0 from?
Where, here?
No, the 0 on the synthetic. Let me see. The 1, 0.
Zero x squared.
There's no x squared term,
Oh, right.
and it has to be accounted for.
I'm still confused on how synthetic division works.
Mr. Rosenthal?
You want me to start back with the long division? Let me answer any questions about the synthetic, and then I can answer questions. Then I can go back and do it with long division. Yes.
Just because I'm not sure what the process is.
Well, do you see what I did? I wrote down the coefficients. You have to account for all the degrees in order. Degree 3, degree 2, degree 1, okay? You put what the solution that they're suggesting is here is that x is 2, okay? One of the zeros that makes it 0 is 2. That, by the way, corresponds to a this factor, x minus 2. You could see by plugging this in for x, it would make that 0. Okay?
Mr.
That's
Rosenthal,
the connection between those. Yeah.
I have class on Thursday and Friday if it's textbook drop-off and such.
No. I mentioned earlier that the last session of this is Wednesday.
Oh, okay. Thank you.
Okay, as you guys...
Why do you have 2 2s?
Well, look here. I removed, what did I do here? I divided I divided an x minus 2 out of the polynomial. I did it synthetically, right? So this was already one factor, right? Once I divided that out, I got a new polynomial who has also x minus 2 as a factor. X plus 4 is also a factor.
Okay, thank you.
All right. So the original polynomial, by the way, looks like this. Let's see, I have more room. It's the x minus 2 that I originally divided out times what was left over was this. So it's this. And you could say that that one's squared. That one happened twice. Okay. This gives me an extraneous solution, the x plus 4, right? Equals 0. Okay. And so all that's left is a 2. 2 could be the only production level for the DVDs. All right, any other questions about the synthetic? Does anybody want to see it done with long division?
Yes.
Okay, I'm going to get the same answers, and you're going to see. So now I'm not using the number 2, the 0. I'm using the factor that it has to go with, which is x minus 2. So you use x minus 2 here, and you're dividing by that binomial, this polynomial, x cubed. Watch this, plus 0x squared. I still put that 0 there. Minus 12x, plus 16. And then you do what you normally do with division. You see how many times this one goes into that one, the leading into the leading. Well, it's times x squared. X squared times x is x cubed. You multiply it back. But you have to distribute because there's 2 pieces. X squared times negative 2 is negative 2x squared. What do you do in normal division? You then subtract, right? Right? So when you do that, I just change the sign and add. Negative, positive, add. You're finally getting to what I did, is that this coefficient was as is. It is already there. All right? The one that dropped down in my synthetic is already accounted for at the beginning. Okay? All right, so whatever that coefficient was, that is going to show up here in the very beginning. All right? Now, that cancels. Then you add and you get this. Right? And you drop down the next one. X goes into 2x squared, positive 2x times. Distribute back. And then change the signs. X times negative 8 is negative 8x plus 16. When you subtract, you change the signs and add, and you get 0. There's your polynomial. Same as before, that factors into x plus 4x minus 2. And if that's equal to 0, then your zeros are at negative 4 and 2, and from the 2 before. Those are your zeros. This is extraneous. You can only have the production of 2 million to get that profit. Okay? All right.
I think it'd be easy to just 2 DVDs and just get $96.
2 million. It's in millions. X is in millions. Yeah. We have some chats. Okay, BC's first alphabet. Okay, how are they getting almost $50 profit from one DVD? Where does it say that?
They divided it.
Not even that much total, not factoring in. You're saying from one DVD they get that profit? Did you plug in?
Approximately. Two times approximately 50 is 96. Oh, 44, 45, 48.
Wait. How are you arriving at that? You're plugging.
They divided 96 by 2.
Why are you dividing 96 by 2?
Because they wanted to find how much each DVD was actually worth.
Is that what this does? This function
No.
gives you the profit.
I'm pretty sure the 72x is how much money you make from from the DVDs. This minus 6x cubed is the cost of the DVDs, like the cost it takes to make them.
Yeah, I mean, any negative value should be the cost, right?
And 72x is the revenue.
Yeah, that makes sense because 72x is linear and revenue is linear. And the more you produce, the more the expenses cost.
Yeah, I guess you need bigger equipment and it costs a lot more money. Maybe after a certain threshold, it actually becomes cheaper again. Who knows?
Well, then how would you account for negative 96?
That's
Oh, it's your addition. Sorry,
Yeah. Yeah, so you're saying that you make, what are you saying? You're making 72.
You're making $72 million for every 50 million DVDs sold. Oh no, for every million DVDs sold.
I guess that's strange to me.
$72 per DVD.
And for every million additional DVDs you sell, in addition to the amount you've already sold, the cost increases as a power function.
I do not want to see that.
Yeah, you're right. It looks like it's too much money for a DVD here. Anyway, but I don't know. Maybe these are connected in a different way. They don't tell you that. So you don't know. We're assuming a lot of things there. Anyway, let's move on.
If we're assuming this, can't I assume that negative DVDs is destroying them?
It is a free country, so you can assume whatever you like.
Thanks.
Sorry, I didn't answer your question. What was your question again?
I said, if we're assuming all this, can I assume that negative DVDs is destroying them? And therefore I can say,
yeah.
negative 4 million?
For the same
You
reason.
might be buying. If positive DVDs is selling, then negative DVDs might be buying.
Might be. I like the word might because you're not.
Why would buying actually raise your profit, then lower your profit?
Yeah, 4 million DVDs would
If
raise
you buy them for less and sell them for more, you're gonna raise your profit.
Yes,
Buy
but
low,
this
sell high. Yes.
doesn't account for them.
It's because you're selling all that equipment.
All right, folks, let's move forward, please. If you look at the title of this, that suggests something. It suggests what we're not doing. If we're finding rational zeros, then what are we not finding?
Not irrational or imaginary zeros.
Right, exactly. That the next section would be imaginary.
So what about irrational?
This one is finding rational zeros when they are rational. What does that rule out? It rules out your quadratic stuff that doesn't factor.
Root 2.
What you're about to learn here is only when you have rational answers, not irrational ones. So yeah, root 2, root 13, the discriminant part of your quadratic formula, the b squared minus 4ac, those have to come out. Those have to come out when you take the square root to a rational number. Okay, so all right, so let's take a look at this rational zero theorem. If your function, and it's some polynomial, all right, I know it's going to take you a second to look at that. There is some leading coefficient, call it a sub n, based on there being n terms in the polynomial. So that's the nth coefficient, right? And it's to the nth degree, and you're going to count down every one. The next one is going to be, the next one down is going to be a sub n minus 1, and then it'll be x to the n minus 1. And you'll keep counting down because we don't know how many there are until at the end of it, you get coefficient a sub 1, x to the 1, right? And then you get the final one, it's a sub 0, x to the 0. Well, what is x to the 0?
1.
It's 1, not 0. A lot of students say 0. So it's just multiplied by 1, a sub 0. So you get your last term is a constant, that a sub 0 there. I should be doing this with my mouse. Here's where I'm looking. Okay, so again, you have n amount of these terms in your polynomial to the nth degree. right?
Actually,
If there are five,
and
if there are five
yeah, and
terms, let's say there are these three, that's all that there is, right? So this is a sub 0 times x to the 0, so you don't see an x, it's just 1. This would be x to the 1, and this would be a sub 1, and this would be a sub 2 x squared, right? So there, how many terms were there? There were 3 terms.
n plus 1.
And why isn't this x cubed then? Because they didn't start with 1, they started with 0. When you count to 3 from 0, you're not counting 3 numbers, you're counting 4 numbers, right? If I say 0, 1, 2, 3, that's actually 4 numbers, not 3 numbers. So here, look,
So
0.
whatever you're doing is in this function, there are n plus 1 terms.
In this function, there are n plus 1 terms. Okay. Well, n here is 2. Yeah. So if n here is 2, right, then there are n plus 1 amount of terms. Yes, you're correct.
1 through n and 0.
Yes. Okay. All right. So now let's actually read what this says. So you have some polynomial, and look at this, really important. And they see how you can really break apart a textbook if you're trying to just get through and read quickly. That might have been why you had bad experiences trying to read a textbook, because you're not really analyzing all the reasons for why did they make this italicized here.
So if
right?
a's are integers.
Integer coefficient only. Okay,
If a is an integer.
right? So integer coefficients only. Then every rational, that's supposed to say 0, I believe. Every rational 0 of f has the following form. It has to be some, I already mentioned this to you. It has to be some p over q, and that's rational by definition if q is not 0, and p and q are integers, right? But it's going to be the factor of constant term a sub 0, factor of leading coefficient a sub n, some factor of a sub 0. So if a sub 0 is 20, your numerator p could be, not necessarily, hold on. Let's say a sub 0 is 20 here. Then p, the numerator of your 0, of your answer, of your solution, the numerator of your solution could be 1, 2, 4, 5, 10, and 20. Why those? Because those are factors of 20. Your denominator q, now we're going to go over here, is those are factors of a sub n. All right? Now, because you have to consider all possible combinations of these things, then you really would want this to be a 1. Because if it's 1, then there's only one factor of 1, or you could say plus or minus 1. So there's two to consider, right? If it's something else, then you have all these other combinations, and you're going to see that now. Okay, so let's try this out. Go ahead right now, see if you can understand, and if you don't now, you will after I do the example. Try to see if you understood what the math says up above, the rational 0 theorem, and see if you can list all possible rational zeros of f using the theorem. Go. And then I'll show you how to do it if you're having trouble understanding that. And what this is going to help you do is if they did not suggest to you in that last problem that 2 million was the target solution, what if they didn't say anything about that? What if they just said, what solution is going to give you? What are possible solutions that will give you a $96 million profit? And then so they didn't suggest that to divide out, and you can't factor it. Then what are you going to do? This is what you're going to do. So this is teaching you how to do it when they don't suggest any solutions to you. So this is giving you more power. It's putting more power and problem-solving skills in your hands when you're doing this. You are not finding the solutions. You are finding possible solutions. Okay.
I say the answer?
You can answer in the chat. Math final. I don't think so, no.
That's certainly a relief.
Two things. One, I really wanted a math final.
Just that we don't have the right.
Well, nobody else does, David.
Two, about the
Why
chat.
did you want a
Everybody
math
said that
Yeah,
it's
literally
not.
no one else wanted a math final.
It's fine. You're
Wait,
not.
why did you want
Hey, here
it?
we go, everybody. Take a look.
Hmm?
Hey, it's important to note that
Would
this,
you
you need, excuse me. These are possible solutions. These are not necessarily solutions. I need to list all the positive and negative factors of 12. So I'm going to do it this way.
Oh.
1, comma, plus or minus 2, plus or minus 3, plus or minus 4.
4 plus or minus 6 plus or minus 12.
Okay. Now the numerator is going to be based on the leading coefficient. Well, it's the 1, so it's just plus or minus 1. This is inconsequential. Why is this inconsequential? Because if I divide by positive 1, it's all of these that you see. Pick one of these, right?
It just switches signs.
Divide by positive 1 and you get 1. If it's negative 1 divided by 1, it's negative 1.
Yeah, so plus or minus is inconsequential, yeah.
Yeah, this is inconsequential. So these up here are your potential roots. This is all possible solutions right here. Now, if that's something other than a 1, if this is a 2, if this is a 10, now you got so many combinations that could be your roots. But at least you have something, you have a lead. So this is going to be all possible solutions. How many solutions do you see here? 1, 2, 3, 4, 5, 6. Double it. There are 12 possible zeros to this function. Okay? That's all they want you to do right now. List the possible zeros. Okay? Because the theorem says that the actual zeros must be a p over a q, where p is some factor of the n coefficient and q is some factor of that, the zero must be from that set of numbers. Okay? Then it doesn't tell you that it has to be all the possibilities, but it's one of these combinations. So now I've narrowed it down to a guess. I can now start guessing. Now, what would be a quick way to check to see if these are going to actually divide into or actually be solutions? There's two ways. You can plug them in and see if you get a 0. All right.
Inequality.
Plug them in. Yeah. If this causes the function to go to 0, then you can check that by plugging in positive 1. Right? It's not asking us to do that right now. We would be done with this type of question. But we can find it. Plug in 1. 1 cubed is 1. 1 squared is 1 times 2 is 2.
I've already been doing it.
11 times 1 is 11, so minus 11 plus 12. Did that give me 0? I have 3, and the 12 is 15 minus 11 is 4. So positive 1 does not give you 0. Then you try negative 1. See what you're doing? You're seeing which one actually gives you a 0 by trying them. Negative 1 cubed is negative 1. Negative 1 squared is 1 times 2 is 2. Negative 11 times negative 1 is positive 11. And that's plus 12. Definitely not going to give you a 0. So the positive and negative 1 aren't zeros. They were potential in the beginning, but now we see that they are not. And basically you keep trying. How many do I need to find? Just 1, because then after I find 1, I can factor it out and make this a regular quadratic. And then I can just solve it to get the others. Or you can keep plugging them in to find all of them. Remember, all your rational zeros. This does not work for irrational zeros, and it does not work for complex solutions. But for rational solutions, it will work. Okay, so if you wanted to keep going, to plug them in, you can. But that's not asking us to do that, and we are going to do those problems in a little bit. So questions about this? This is your answer right here. So the theorem says that the solutions to this, the roots of that, the zeros of that, have to have this property to it, where it must be your solution must be a p over a q, which is a rational number, in which the p is some factor of the last term, and q is, now I would love to see the proof of that, but we're not going to do that, and I don't know it. Okay, and then q is some factor of the leading coefficient. All right, so right now it's just an algorithm that you kind of have to remember. I don't like that, but you can put it to your teacher, Mr. Nuno, next year, if you're staying with us. You can put it to him to ask him why, and settle for nothing less than I'll get back to you on that, unless he already knows the proof for it. Then he could show it to you. Okay, but if he doesn't, see if you can get him. I don't mean to put more work on him, but put it to him that from what you learned from geometry is the question should be, is there any way you can, find out for us? Or you can try to find out on your own and then tell him, I didn't understand. Is there any way you can explain how to do that? That's up to you. I don't want to push you guys into revolting against your teacher to make sure he tells you why, because, Richard Feynman always said, he didn't always say, he said in this one famous video that they captured, you can always keep asking why. At some point you get to a place where you don't have enough prerequisite knowledge to understand the answer. And that's about as deep as you can go with the why. Okay?
Mr. Rosenthal,
You can keep continuing to ask why indefinitely. Yes.
Mr. Rosenthal, have you ever met the new teacher?
Yeah, I interviewed him. I didn't meet him in person.
Is he
Okay.
nice?
Wait, so Mr. Rosenthal, the
Which
P,
one was it?
Mr.
All
Rosenthal, the
Yeah.
P is all factors of the last term, right?
Yeah, and I'm going to show you. Look, they solve it too.
Wait, can you leave that function right there, please?
Okay, and then the Q is what the A is. in the
Yeah,
function?
right here. Yeah, see it? Plus or minus 1, because this is a 1.
Okay.
And you can get a 1 with a -1 times a -1. So all the negatives are also factors.
So
What
all-
exactly is a
all
constant term?
That's the 12. Constant, right? It has no variable in it. It's the last term in the polynomial.
So all
Okay,
of
but
them,
what about 6 and 4 and 3?
Okay, so these are factors of 12, aren't they?
Oh, factors of 12. Okay.
And these are what your possible numerators, look over here. That's what your possible numerators are for your solutions.
Oh, okay, I get it.
Isn't that cool that your solution has been there? Now, if you go back to quadratics, it's there. If you want to solve a basic quadratic using this, you have a way to look to see what possible solutions are.
This function has no rational zeros.
Oh, it doesn't? You tried them all?
It has no rational zeros. I tried all of them.
It might not. Yeah, if you try them all and none of them give you a 0, then it has no rational zeros. There you go.
Positive 1 is 4, -1 is 24. Positive
Okay, you don't
2
have
is
wait. You don't have to go through all of them. Either you're correct or you're not and you made an error. Okay. Any other questions before we go to B? See how they simplified these fractions because the denominators are 1? So they're just the numerators. If it's not 1, then some of them have, hold on. If this leading coefficient is not 1 like it is here, you're going to have to deal with a lot more combinations, right? Even if it was just 2, well, there are 2 factors of 2, 1 and 2. So you have to do all of these over 1, the pluses and the minuses over 1, and all of these again all over 2. So it could turn into a ton of combinations. Okay, try this one, like in this case. But all they want you to do is list them. Everybody do B. Now you're going to get a bunch of stuff here now. Oh, okay.
That's a lot.
Yeah, it's okay though. Okay, still going?
48 choices.
Are there?
What are your possible zeros?
Okay, don't shout stuff out. Go ahead and chat that. Okay, so if you're trying to be organized, you might want to just list all the factors of 10. And it's always plus or minus because it could be 1 or -1, right? So I would say factors of 10 are 1, 2, 5, and 10. Factors of 4 are 1, 2, and 4. And you need to get all the plus or minuses. Okay? So this is the P, by the way. It's a little counterintuitive. This is the Q. Some of you might put these over those. You might do the Q's over the P's, and you'll get them wrong. Okay? Some of them will be right because you have some of the same factors. Okay? But you would get the other ones wrong. Okay? So remember, it's the last one over the first one. Try to remember that. Make a note to yourself. And you'll be reminded when you do it in the fall. Okay. So what I need to do is I need to have plus or minus 1, comma, plus or minus 2, comma, plus or minus 5, comma, plus or minus 10 over plus or minus 1, plus or minus 1, plus or minus 1, plus or minus 1, plus or minus 1. Now, you're going to do these all again. Plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10 over the second factor, and it's plus or minus also.
Wait, Mr. Rosenthal, when you plug it in, do you plug in P first and then divide everything by Q, or?
Let me just finish the idea and maybe you'll see. Maybe it'll answer your question. And then the final combination is for this set of P's, 1 plus or minus 2 plus or minus 5 plus or minus 10 over the third factor of 4 plus or minus, oh, sorry, I want them individual. Plus or minus 4, plus or minus 4. Okay, so now let's think about all of the combinations we have. What could this be? You either have positive 1 divided by
plus or minus 1.
Right, so this is plus or minus 1. Okay, this is plus or minus 2, plus or minus 5, plus or minus 10. So there are 1, 2, 3, 4, 8 possible solutions here. Okay. Over here, it's going to be plus or minus 1/2, right? What's this next one? 2 over 2.
Plus or minus 1, so you don't need to show that.
Exactly. I don't need to show this. This one's redundant. Okay, next one. This is plus or minus 5 over 2, which I don't have yet. This one is plus or minus 5, which I already have. This one's redundant. This one is 1/4, plus or minus 1/4. Plus or minus 1/2 is redundant. Plus or minus 5 over 4. And then this one is going to be plus or minus 5 over 2. This one's redundant. That's it. 1, 2, 3, 4, 5, 6, 7, 8, 16 possible solutions. All right? So
and some of them are 1.
So when you get so many like that, it's going to be annoying to try to plug in every single one to try. So what you really want to do is find one of them, plug it in, and then divide it out to make this polynomial 1 degree less, right? Find another factor the same way. Get it out. Get it down to a quadratic by dividing out factors that you've located. So that you only
That's 4x to the 4th minus x cubed minus 3x squared plus 9x minus 10, right?
Yeah. Okay, but this is the answer to the question. These are all possible solutions to that polynomial based on our P over Q. P, Q. Factors of P over factors of Q give you all your potential solutions. Okay? Questions about that? And there they are. Okay. Second opportunity for questions now. Nobody? Giving you time to absorb and reflect and share if you have any questions. All right. And raise your, or not raise your hand. Oh my gosh, you hear what I was saying? Let me know if you need more practice. I don't actually see more practice right there. Maybe, oh, I don't have anything to offer you. Okay, now look at the question. It does, look at the question before and compare it. List the possible rational zeros. Now what does it say? Hello?
I know real zeros.
Not rational now. Find all real zeros. So I'm going to let you go right there. Use what you've been given. Use all your skills and see if you can get to the, see if you can find all the zeros, the real zeros of this. No complex. Good luck. This should be satisfying if you do this on your own. And if you don't, then the next one, I want to get you to where you can do this on your own. And I think if you're doing it right, you're going to get 12 possible rational zeros. You're going to get 12 possible rational zeros. And then you're going to have to find, and I would do it in an organized way, find the one. Find the one that you're trying to do. And then try to divide it out. I'm going to use synthetic division to divide that out. Once I find that zero, I'm going to put that up there like my K, and I'm going to just use the coefficients, and I'm going to find out what that divides out to, get a quadratic, and just solve the quadratic like we know how to do from last year and from last chapter. I'm just going to set myself up to do it. I'm not going to do it yet. And I'm going to cut to my screen now. Okay, as you should be way ahead of me now. I'm going to start listing all my possibles. So, and because my leading coefficient is 1, it's all going to simplify out to whatever these numerators are. So I'm not going to even write the other ones. Okay. Oops. Oh yeah, so I'm listing factors of 20. So 1 plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. 1, 2, 3, 4, 5, 6, 12 different possibles. Now, what I want to do, the book tests by using synthetic division right away.
Yeah.
You can do that. Or you can plug in and test by plugging in. So if I plug in a positive 1, if I plug in a positive 1, 1 cubed is 1, minus 1 squared is 1 times 8 is 8.
I just redid synthetic division with each one until I found one that worked.
That's what the book does. And
yeah, it took a very short amount of time though.
Yep. Keep going though. Once you find your first root, divide it out and then solve the quadratic.
Wouldn't it be faster to just plug in each one?
It depends on the person. Synthetic division, the whole purpose of learning it is a quick way to divide so that you can get to it quickly. That's why we learned it, so that we can do these quickly. Okay, here we go. -7 and taken away from 31 is not going to be 0. So it's not, +1 is not a root. -1. -1 cubed is -1. -1 squared is 1 times 8 is 8, so -8. 11 times -1 is -11. Plus 20. And it looks like, there it is. So -1, when I plugged in -1, I got 0. So -1 is a 0. All right, so x equals -1. That means one of my factors is x plus 1. Okay, one of my factors has to be x plus 1. So if I want to divide that out now, you can use long division. I'm going to use synthetic division. Okay, 3, 2, 1, 0. So it's all set. 1, -8.
I'm out of fading.
Okay, straight down. -1 times 1 is -1. Add. -1, by the way, -1 and -8 is -9 here. See, when I plugged it in, that's what you're getting. Okay, -1 times -9 is 10, is +9. Add, you get 20. -1 times 20 is -20. Add, you get 0. Okay. What am I left with? I'm left with 1x squared minus 9x plus 20. And what I want to do is to solve for the solutions of that. Don't forget, this was one of your factors. So if that's equal to 0, okay, that's going to factor into, does that factor? Yes, 5 and 4. X minus 5, x minus 4. Okay? So your original polynomial is this x plus 1 times x minus 5 times x minus 4. That's what f of x is. You have now factored. This is the factored form of that polynomial. And you have all your zeros now. The first one you found was -1, then 5, then 4. Notice that -1, 5, and 4 could have been found here, right? You could have, but look at how long it would have taken you. You would have gone through 2 and -2, fail, fail. You would have tried 4, success, -4, fail, +5, success. And you could have gone through that way without doing the synthetic division. But this got me quickly to my other 2 solutions.
Instead of testing 12 different solutions.
And what if the final solution was -20? It was on your last one. You don't know that. You don't know which one it's going to be in the beginning.
Why would I do -20 last?
I don't know. So any questions about this process?
Mr. Rosenthal is confused about why I was asking that.
Yeah, I still am. Okay, I'll take questions. Okay, see, they listed all their possibles. Okay, what are these numerators? They're all factors of 20, plus or minus. And then the ones down here are all factors of this A coefficient here.
Oh, that could have been faster. Yeah, I accidentally just tested the positive ones, and that's why I found it on 4 instead of -1.
Yeah, you're always welcome to try them in any order you like. Okay, so what did they do? They found that -1 is a 0 because it came out to as no remainder, right? So then what they're doing is they're factoring that out, and then they're getting this quadratic here. And then they factor the quadratic into x minus 4, x minus 5. And though all your zeros are what make each of these groups 0. X is -1, x is 4, x is 5. All right, you all are going to try number 3 right now. So hopefully, if you're getting this, you now have a way to do that application problem without them suggesting what the production level should be. So I should be able to go back to that problem and say, using that same polynomial function, how do I get a profit of $1 billion, right? How do I get a profit of this or that? What will I have to produce? And what happens is you can break your model doing that, because models are not, they're trying to model the real world. So they really only work usually in local circumstances. And I don't mean local like in your city. I mean, that function works up to a certain level. You can't go infinite amount of shoes, right? So practical, in the practical sense, that model will break if you try to use it outside of some domain and range, some real domain or range. Okay, I'm going to start doing number 3. You've had a nice head start while I blabbed. You caught me monologuing. That's from The Incredibles. Syndrome. Okay, I'm going to cut to mine because I copied down the function. I'm going to list my potentials. It's nice when they give you a 1 here. -1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, plus or minus 18. Now you can use synthetic division to test these, or you can plug in. It's up to you. Some of you are very comfortable plugging in, okay? It's fine. I'm going to use synthetic division. So I have 1. The thing with synthetic division is if you're wrong, you have to keep writing all this stuff up here.
Pretty easy. I mean, the first term is the factor.
I hit a 0 on the first try. Hole in one, we'll call that a hole in one.
A hole in one is called an albatross.
By the way, what binomial accompanies a solution of 1?
X minus 1.
Yes, x minus 1. That would make that a 0. So you know that you can factor out an x minus 1. And what you're going to get now is you're going to get, hold on, David, hold on. What you're going to get is you're going to get this. You're going to get x squared minus 3x minus 18. And that is waiting to be factored. So that's going to be 6 and 3. So it'll be 3 and x plus 3x minus 6. Okay, and you can say, when is this function equal to 0 would give me my zeros. So my zeros are 1, -3, and 6. And that was quite neat. That was a neat problem. Not that it was cool. That's not how I mean neat, although you might find it cool or neat. What is the term students use now these days for cool? That was cool.
Pretty much just cool.
Oh, okay, so that's back. That used to change every 5 or so years. That would change into something else. In the 80s, we said rad. That's rad.
Rad cool.
Yeah, short for rad.
Ironically say that.
Yeah, but now it's like that's retro now, so things come back.
I don't see what's wrong with the word good.
We don't say groovy.
Although we should.
I don't see
Groovy is a
what's
great
wrong
word.
with the word good, though. It's perfectly
Nothing's wrong
satisfactory.
with it. Nothing's wrong with it.
Also, David, a hole
There's
in
a
one
slightly different meaning. Good is different than cool. Cool
David, a
does
hole in
not
one is
mean-
not an albatross. It's 3 under
No.
par.
What?
An albatross is 3 under par, not a hole in one. It's only albatross is only a hole in one if it's a par 4 hole.
I've never
Okay.
heard
It's a
of
par 3 or a
No.
par 5.
I revised myself. A hole in one is
An
a hole in
eagle.
one.
An eagle is
But an
four,
albatross
right?
is not 4 below par. An albatross is more like.
Albatross is
An
3 under
albatross is
par.
3 under
Eagle is
par.
2 under
An
par.
eagle is 2 under.
An
No.
albatross is a bird.
Yeah, that's
Albatross
true.
is 3
Okay.
under par. Condor is 4 under par.
Galaxy bird.
All right. I take any questions for 3. Otherwise, I'm going to move on to 4. You guys can start 4.
I just know this from Wonderput.
Start 4, everybody. I'm going to erase and set up my number 4. Oh, we're out of time. We can start with number 4 tomorrow. Dismissed. I'm on office hours.
Thank you, Mr. Rosenthal.
Thank you.
Thank
Enjoy.
you, Mr. Rosenthal.
You betcha.
Thank you.
Absolutely.
Thanks.
So what exactly would you think, Mr. Rosenthal?
What?
What exactly do you think would be different between the two words? Different enough, at least.
Okay, so good has a lot of different meanings, right? There's morality, there's a value, right? In being good, being a good person means you're moral, you have ethics, maybe. All right.
Who is caught up on all the work?
Cool doesn't mean that. Cool means interesting, almost, right? If something's cool, it means it's interesting to you.
Interestingly good, then.
That's a combination. That's fine.
Intriguingly good, and that would completely satisfy the purpose.
But you wouldn't say good, right? And if cool means good and cool means interesting, and you want to say interestingly good, that would be like saying good with the transitive property, right?
Well,
Goodly good? Is goodly even a word?
all right, that's kind of stretching it there. But I don't see the necessity. Why is it that just from sort of sociological perspective, how is it that they invent a new word for the same meaning every decade or so?
Well, how did they get the word in the first place? How did they get any words in the first place? Who's the authority that makes words? There isn't. There's no authority that makes words. There's no word, no person that gets a credential or some degree in or gets hired or everybody agrees this person is the word creator, the creator of words. No, words are agreed upon by society.
I looked it up. You were right. Albatross is 3 under par. Condor is 4 under par. Ostrich is 5 under par. Eagle is 2 under par. Bird is 1
How do
under
you
par.
have 5 under par? You would have to have a par 6.
Very difficultly.
You'd have to have a par 6.
What is this discussion? What is this subject?
Yeah, an ostrich is acing a par 6.
I've never heard of a par 6.
What is this discussion?
It's a golf discussion.
Ah, I see. That's
Golf
what I
is
thought.
actually golf is interesting.
Eagle, albatross, condor, ostrich.
Winning scores are negative numbers. It's the lowest score wins. The fewest amount of shots required to get the ball into the 18 holes.
The most surefire way is not to win is not to play.
You can't
Hashtag wargame.
not play. That's the sure way to lose, is not to play.
No, you have a score of 0.
Yeah, but it's negative scoring.
Yeah, but if somebody has a
0 is less than any other score that someone who played can score.
no, if the 10 top players in a tournament are all under par. And by the way, 0 in golf does not mean 0 points. What it means is you're on par. So if it takes you, if they suggest that a shot on average should take you 4 shots to make it, then par for that hole is 4. Scoring a 4 is actually a 0 because you are 0 points away from the suggested amount.
Okay, well that's not how I played it. We just stacked up points.
Yeah.
Just the number of shots it took to get to the hole.
Yeah. But that's not they don't score it that way. They don't count how many shots that you've taken. What they do is they say how many shots below the suggested amount or how many shots above the suggested amount. It's an interesting scoring routine.
Thank you, Mr. Rosenthal. Have a good day. See you tomorrow.
Okay, you got it.
Bye, Mr. Rosenthal. Okay.
Anybody else? Questions? All right. I'm going to end session. Have a great day. I'll see you tomorrow.